So now I'm going to discuss about the next important factor, which is pressure. In the previous video I have discussed about the volume, so now I would like to discuss about the pressure. So let's go down. Okay, I need to go more down for it. You know, the clean board. Okay, it's a perfect read. Now correction and pressure. Correction and pressure. So we will understand this term in terms of two concepts, correction and pressure, right? I'm so sorry. So first of all, I'm going to talk about ideal. Then I'm going to talk about the next one, which is real. So in the ideal gas, we know that if I just draw it, it's something like this. I need to see this function. We know that this is a wall of the container. The molecule collide with the wall of the container. There is no force. If I consider there is a point mass, this point mass does not attract this point mass. Just by moving with the velocity v1, colliding with the wall of the container with the momentum, and moving back with v2. Right, but since there is no force of attraction between them, so no pressure. The force is generated, there is no pressure. Because force acting on the area of the wall of the container produce pressure. But if you consider real gases, so this is the molecule. First of all, the molecules are not of a point masses. They are spherical, rigid spheres, right? So these molecules collide with the wall of the container. But since they are molecules that are present here, attract these molecules. The force of attraction is between them. Like this, these forces are attracted to which it restricted the molecule to collide with the wall of the container. We'll explain it with the help of an example that we can get from here. Pressure correction picture by van der Waal, right? By van der Waal, right? So pressure correction picture by van der Waal. Okay. So let me just get the picture here. Okay, so we can keep the picture here as for reference purpose. So let me draw it. So sorry, I'm so sorry. So we can draw that image here as well. This is the wall of the container. This is the, for example, this is a molecule A, which is colliding with the wall of the container, something like this. And the molecules, these are the molecules that are attracting the molecule A, right? This is for same for this molecule attracting. I'm so sorry. If we consider another molecule which is collided with the wall of the container, and this is a molecule B, we will consider the same case for the B molecule as well. For example, this molecule is amine, and this molecule interchange with each other. For example, A molecule can behave like a B, B can behave like a A. Just because this A and B molecule collide in wall of the container, while the other molecules are attracting them. So A can be B and B can be A. So we can write here concentration of A which is equals to mole divided by number of moles divided by volume, and so as for concentration of B, right, which is mole divided by volume again. So this is let me write it here. Concentration of A, which is okay, wait. Concentration of A is equals to N divided by V, and the concentration of B is equals to N divided by V. So overall concentration, which means A and B, is equals to A and N divided by V multiply, we can represent with the help of dot, N divided by V, which is equals to A N square divided by V square. So this is actually the corrected volume. This is I'm sorry, not volume, this is a slip of tongue. So wait. This is actually a corrected volume, and overall a term that we have to write here is something like this. P is equals to total pressure is equals to P plus P. Now what is internal and external here? I'm going to discuss the P, I and Q, which is P internal, which is something like this. P total pressure is equals to P plus A n square divided by V square, right? This is something like this. Now what is there are two pressures that are involved here, two pressures. Okay, I'm gonna write that on the sticky notes. Two pressures. Two. The size is too giant. Uh, okay, let me try it again. Um, two pressure here. Pressure. Okay, so this is very giant. I must leave it. So it's a little bit confusing for me as well. So let's leave it. Wait. Okay, wait. Okay, so this is done. I'm gonna write here simple words. Two pressure involved here. Two pressure involved here. One is internal pressure, and external. So what is the difference between internal? For example, these are the molecules here. Okay, so let's wait. These are the molecules here. So this is a rigid sphere molecule colliding with the wall of the container, but other molecule is attracting these molecules. So this is internal force that is acting here. This is the same case as well. So okay. So this is internal. What is the significance of B? Significance of A. Significance of A. And after that, I'm going to discuss about the significance of A. For example, it's an attractive force. It's an attractive force. The first thing, which means that the higher the value of E, the higher the value of A, the higher the force, the more it gets liquefied quickly. Yeah, the higher the force, and it gets to liquefy quickly, and maybe it's not visible here. So wait, and it gets liquefied. It gets liquefied quickly. It gets liquefied quickly. Liquefy quickly due to high force of attraction. Now why liquefy? Just because when the pressure is high, for example, this is a container. Pressure is high, molecules are closer to each other of the rigid sphere. No, and until a point, at an instant point, they have definite volume between it, due to which repulsion force become dominant with z factor is greater than 1, due to which at high pressure and low temperature it liquefies. At high pressure and low temperature it liquefies. Right now talking about the unit of B. So for that we need to move down. Wait. Unit of B. Unit of B. We know that B जो है unit of A, I'm sorry, I made a mistake in here. Unit of A is equals to P plus A n square divided by V square. So this which is equals to P which is equals to P total. Right. So P total is equal to P A n square divided by V square. This is something the term that is given here. We know the pressure is equal, which means the unit is equal to ATM dm power 6 mole minus 1. So this is basically a unit of A. So this is something about the A, right?